Swayam Prabha. Digital India. Educated India.
Just imagine that I am a train that you're so desperate to catch after your midterm exams to reach your respective destinations where you come from. Somebody comes from Delhi, somebody comes from Bihar, somebody comes from the south. Who comes from the south? Okay. I'm lost. So, let me rephrase. How many of you guys are able to catch your respective trains to your destinations on time? Who has missed a train to his or her house so far? Nobody? Was that? Was that? You have missed a train? Once? Twice? Once. From where to where? Chennai to Vellore. Anyhow, forget about that. Okay. So this Friday and Saturday, you're going to be having your AutoCAD labs. Okay. So the plan is the same as last week. So 2 badges per session, both on Friday and Saturday, forenoon sessions on Friday, afternoon sessions on Saturday. Okay. So if you go through my web page, I have chosen 6 problems. 1, 2, 3, 4, 5, 6. Okay. So go through my web page. You know which session you belong to. Click on the respective problem. Prepare the sketch. This time you're going to be getting only 1 hour to work on the AutoCAD lab. So prepare your sketch as well. Make sure you understand the object very nicely, very well. Okay. Go to your respective AutoCAD labs, work on the object, submit the problem, and get graded. Okay, so Friday and Saturday we have AutoCAD labs. Okay, I won't be there, but 2 of my students, Mohit and Ramesh, they'll be there to help you out, and of course collect your assignment sheets. Okay. So was a little announcement. Let's get started. So a little recap. So I started with this example last week, and started with the top view and then drew the front view, and we both agreed that the front view was quite congested. It had too many hidden lines, solid lines, center lines, and that was something that we wanted to avoid. And one of the options was to, of course, section an object into 2 parts and look at the section and draw the front view. Okay, so there were different options that we had explored last time. The first one was the full section view. You take a section, you essentially divide the object into 2 halves. Okay, just throw one half off and look at the object. Okay, with the section plane incident towards you, and then you draw the sectional front view, which is a lot much clearer option. Okay, So the first choice, full section view. The second choice was the half section view. You can use the symmetry of the object. Just take 1/4 of the object out. Okay. On the left hand side in this example, you can choose to show the features as if you are drawing the orthographic view of the object. Full details, hidden lines, solid lines, center lines. The right hand side, you can choose to show the sectioned view. Okay? So you have clarity over here, you have information over here, half and half. Okay? Option 2, full section view, half section view. Then you've got offset section, where you choose the section plane to pass through different features of the object in the top view, and correspondingly section the object in the front view. Full section, half section, offset section, revolved section. So this is an option that you choose to show the cross section of an object. Okay, cross section, not the section of an object, but the cross section of an object at some chosen section plane. Chosen section plane, cross section of an object. Okay, revolve the cross section to show that on the front plane. Okay, fourth option. Fifth option, removed section, very similar to revolved section. You choose a section, okay, and show the cross section of the object in the front view, not with the front view, but maybe a little below or on the side. Okay, that's the only difference. And of course, aligned section. Here you tend to align different features with the section plane and then show the section front view with two things in mind. Number one, clarity. Number two, true dimensions. Okay? For example, Kevin last time said that, you know, if we did not align this thing along with this section plane, we could have taken the projection of this rib over here. Okay? That would not have shown the true dimensions of this rib in the front view. Okay? And that's the reason why we tend to go for aligned section in cases where our objects are not symmetric. Just a little recap, we had seen this last time. For clarity, standard parts, of course, they are not sectioned. Okay, even when the cutting plane passes through them. So some of those parts are shafts, nuts, bolts, ribs, spokes. Webs are sectioned, lugs are not sectioned. Okay, some examples that you had seen last time. Bottom line, sectioning pertains to trade-off between information and clarity. Okay, you have to choose what kind of information you want to give, and alongside you have also to choose how clear you want your section view to be. And these two terms, information and clarity, pertains to both features and dimensions. Okay, so since we are working with, so to speak, orthographic projections, I mean section view is in a way orthographic projection, you need to show true dimensions. Of course, rules of orthographic projections are relaxed when we are working with sections. Okay, we don't have to diligently follow those rules. Supporting and fastening elements that do not participate directly in the main machine part are not sectioned. Essentially, I refer to these: ribs, lugs, bolts, nuts, spokes, shafts. These guys, they are not sectioned. Okay? But then there's this big question. When do you decide what to section which part? I'll share a little secret with you. So this is a problem that was rejected as a mid-sim problem for you guys. Question number 4. Okay, but that's okay. I mean, don't get any ideas that I'm going to be asking you this problem. Okay, that's not going to happen. So I chose this problem. I started working on the solution to this problem. Okay, so you have a big cylindrical feature over here, a small cylindrical feature over here, and this feature on the right, and these three features are connected by this guy here and this guy here. One look and the impression that you're going to be getting is that these two guys are what? Huh? What are these two guys? Somebody said ribs? What are they? No clue? So let me rephrase this question. Do these two parts participate in the main machine part? Are these important? Both of these. So if I want to take a section of this object from here till here, okay, bottom through, will I be sectioning these parts? Yes or no? Yes. Absolutely sure. Positively sure. Definitely sure. So these are not ribs. These are not ribs. Fine. I chose to represent them, or I chose to depict them as ribs when I was working on the solution for this. So I didn't section them. I sectioned only the three main features: the center cylindrical feature, the top left cylindrical feature, and this one. I didn't section the two parts in question. And we sat, we discussed this, and one of my colleagues said, well, you know, this doesn't seem right because they happen to be a part of the main machine part, so they need to be sectioned. So the entire thing gets sectioned, so there's no point asking you guys to work on this question, because you're going to be drawing the outer profile in the front view, and you're going to be sectioning everything. Okay, so the entire thing is going to be hashed. I agreed with him. Okay, so these guys, they need to be sectioned. But you know, you guys are smart. Very soon, you'll figure a loophole in these rules. Okay, I can foresee that, and this is one of the things. This is one of the counter arguments that you guys are going to be giving me. How about pulleys or wheels with spokes? Are spokes not the main part of the pulley? Because if you remove the spokes, then the central part is hanging in the air. What do we do in that case? Should we section the spokes as well? Yes? No? See, you guys are divided. Who says yes? Long hands. Both hands. Who guys, I mean, who of you say no, of course? The rest? Okay. Are you expecting me to give you the right answer? I won't. I will not. So there are certain questions for which you need to find the answers for yourself. And I've given you two options: either refer to your Bible or ask God. Okay? Bottom line is, yeah?
Sir, there can be various perceptions whether an object is a supporting element or not. So will you say that only this is the correct answer and the rest not?
See, the moment you say there can be various perceptions, you are introducing subjectivity.
But there is subjectivity in deciding whether an element is supporting or not.
Absolutely. So in this case, yeah?
Is there a correct answer for these type of questions? Or there can be various answers, various possible solutions?
Find the answer for yourself. You know, I told you something about what is right and what is wrong quite some time ago, na? So find the answer for yourself. So in this case, you make the judgment that these guys are not to be treated as ribs, and therefore they need to be sectioned. Why? Because they happen to be the main part. They happen to be participating in the main machine part. On the other hand, these guys happen to be quite important to some, not to all, but you choose not to section the spokes. Okay? Judgment is to be made. Yeah?
All supporting elements behave similarly. If you remove the judgment holes, the machine part will be nothing. If you remove any supporting element, the machine part will obviously not be supported and they will not be fastened. That's why they are called supporting and fastening. If you remove the spokes, you are saying that it will not support the part will not be supported.
No, so ribs, think about the ribs. What do they do? You remove them, you still have the object intact. Fasteners, they are essentially different components. They are different from the main machine part. Right? Right? No. So I'm not talking about the assembly. I'm talking about a single part in the assembly. A single part in the assembly. I'm not talking about the entire assembly. Of course, I mean, if I remove the bolts and nuts from there, the assembly is going to get dismantled. Fine. But I'm talking about a single part. So go back, ask yourself this: what is important and what is not? Ribs, question ribs. Fasteners, question fasteners. Spokes, hubs, question everything. Okay? Do a little bit of reading, everybody. A little bit of reading. Follow the conventions and make a judgment. Try to develop some sense of judgment as to where you're going to be sectioning what. Okay? All right? So there's certain conventions that you need to follow. Okay? And you need to be finding the answers to these yourself. Of course, I've actually given you some help. Okay, so if you have looked at that PDF document, more on sectioning, you'll get something from there. Yeah?
So like there was a lug in the first machine that was built. Isn't it an important part? Like without it, it may be possible that the functionality of machine is destroyed. Like there will be something more than making the part rotate or
You're thinking, huh? Think a little more. Find the answer for yourself. I'm not going to be giving the answer. So don't cajole me, don't coax me. I'm not going to be giving the answer. Okay? I came here with my mind made. I'm not going to be giving an answer to this thing. Anyhow, so keep working. So something that I want to talk to you guys about. You know, you guys are in your second semester. You still have 6 more semesters to go after this. So it's a long marathon for you guys ahead of you, 3 years. The way I see, and it was not a long time ago that I was sitting along with you guys, the way I see from both ends of the table that instructors help you guys prepare for treasure hunt. You know, at the end of your 8th semester or 7th semester, you get something called a pay package. Pay package, treasure. Okay? Exposure versus expertise. Okay? So we don't expect you to become experts at the BTech level. This is, when I say this for myself. I do not expect you to become experts after your BTech. On the other hand, I expect you to get exposed to a lot of subjects. You guys are going to be doing 6 courses a semester starting your second year. Okay? So we will expose you to a lot of subjects and expose you really a lot. Okay? So this is what we do at the BTech level. This is what I do at the BTech level, expose you guys. Okay? It's up to you whether you would want to become an expert or not. At the end of BTech, if not a problem. Definitely you have got something called the master's program, definitely you have something called a PhD program where you learn more about any subject of your choice. Okay? So do not expect yourself to become experts of subjects after you BTech. It's totally fine. Know a lot, okay? And it's okay for you not to know everything. It's perfectly okay. Right? We give you hints. It's up to you how to use the hints for your treasure hunt. All right? Okay. I'll talk about sectioning of assembly today. So this is the example that your 6.3, problem number 6.3 of your 6th lab. Okay, this example pertains to that. So feel free to make sketches if you want to. So you got 4 parts: base plate, you got 2 brackets, you got a pulley, and you got a shaft. Okay, once again, you got a base plate, you got 2 brackets, you got a pulley and a shaft. You need to arrange them together into an assembly, into a sensible assembly, okay, and show the sectioned front view, full top view, and I'm not sure if I asked you to show the profile view. Did I? Anybody having the manual? Did I ask you to show the profile view as well? No? Just the full top view and section view. By the way, in all the examples that you have seen today and the previous lecture, which view did I section? Was it always the front view? Or some examples top view, some examples profile view, just the front view? What? Front? Only the front view in all examples? Yeah? Why? Why not top? Why not profile? Why only front? Why only front? Why not top? Why not profile? Priority, FTP. Okay, so front view is the topmost priority view, then comes the top view, then comes the profile view. Okay, so you would want to show as much details as possible with as much clarity as possible in the front view. Okay, and then comes the top view, and then comes the profile view. Right? So by convention, this is my impression, by convention that people tend to section front views mostly. Okay? Rarely have I seen somebody sectioning the top view and the profile view. All right, so these 4 parts. Base plate, you got dimensions 150 by 80, 4 holes, 4 arcs. There's a little groove here. Okay? There's something over here, something over here. Where would the brackets go? Where would the brackets go? Here or here? Look at the dimension. Look at this dimension. Where would the brackets go? Okay, so I'll give you a hint. The brackets will go over here. One here, the other one here. Okay, so this guy is going to go just like that, and if you flip this guy, it'll come here. Okay, between the 2 brackets, you'll have a pulley which is supported by the shaft. Okay, so let me start drawing. Okay. Do you have any questions so far? Any questions? How I wish I could be sitting on there and dozing off. Yeah? It's like a puzzle for you. I've given you different parts, you need to fit them together. You got the numbers, no? You got the numbers, dimensions. What's the best way to assemble these guys together so that makes sense? Study this problem when you're working on your sketches. Anyhow, so I'll start drawing. I would want all eyes on the screen. Things are going to get nice and messy at the same time. Okay? So if you think about this, all you need to do when you're drawing the sectioned view of the assembly is to just cut and paste the respective front views. Okay? Nicely. Cut and paste the respective front views. Okay? This is what I'm doing. The base plate, don't worry about the dimensions, don't worry about the projections as yet. Yeah? Base plate, quite simple. You got two cylindrical voids, and then you got a bracket on the left, a bracket on the right. I'm going to go a little slow. Got the ribs on the bracket, center line, two little holes in the bracket, countersunk or counterbore. Okay. A cylindrical void to allow the shaft to go in on both sides, the center line. I think your brackets are done. You start working with the shaft. So this is your shaft. A little taper on both sides, and then you start drawing the pulley. That's to be housed over the shaft. So I'm a little careful here. Okay, I'm not showing all the details that you actually see in the respective front views. There are certain lines which are going to be missing, of course, because I have taken the section plane, okay, and I've cut the entire assembly, half and half. Okay. Good? Huh? What? This is how easy it is. So I got the base plate there. I got bracket 1 over here, bracket 2 over here, flipped. I got my shaft over here, over which I've got the pulley. Of course, everything is sectioned. So many lines. Messy enough? Huh? Messy? Capital M, capital E, capital S, capital S, capital Y? Huh? Or I? The soccer guy. Lionel Messi, na? Okay. This is where things start getting beautiful. Wait and watch. Hatching lines or hash lines at 45 degrees, okay, The distance between two hashed lines is almost uniform. The brackets are sectioned differently. Okay, the left bracket positive 45 degrees, the right bracket negative 45 degrees or 135 degrees. You would want to avoid something like this in your diagram. It needs to be perfect. And then you start hatching the base plate. Again 45 degrees, but with a larger spacing between the hash lines. The pulley, again larger spacing, minus 45 degrees. Messy and beautiful? Huh? Yes? No? Was that? Why larger spacing? These are 4 different components. These are 4 different components. They have to be shown using different hashed lines. 45 degrees less spacing, 45 degrees minus 45 degrees less spacing, plus positive 5 degrees more spacing, minus 45 degrees more spacing. So people tend to use 30-degree hash lines, 60-degree hash lines at times. Okay, so there are different conventions that people tend to follow. Do a little bit of reading. Okay, it's a different component. It's perfectly okay for you to want this to be positive 45 degrees, want this to be negative 45 degrees. All you need to show using hash lines is that these are different components. Okay, 4 different components. The ribs are not hashed. The shaft is not hashed. Okay, and then I'm going to be introducing fasteners or bolts. They will not be hashed. Good enough? They should be lighter than the solid line, so maybe 2H. Okay? So this is where you can practice your art in technical drawing. Okay? So make this as beautiful as you can. All right. Yeah? Then what? So as I said, I mean, people tend to follow different conventions. So at times people tend to use hatching so that there are like 2 hatched lines which are very close to each other, separated by a gap, followed by 2 again closely placed hashed lines. You can vary the degree. So I actually have chosen plus 45 and minus 45, but you can work with plus 30, minus 30, plus 60, minus 60. Okay? Don't make them vertical because they get confused with you get confused with these lines. Don't make them horizontal, doesn't make sense. Okay, slightly slanted. So the range is 30 to 45, 30 to 60. Okay. All right. Nuts and bolts. So people use different conventions. I'm going to be introducing you to one of them. Okay. Of course, for the bolt, you got the head, okay, which is hexagonal in nature. You can actually have square heads also. There are different kinds of bolts. And then the shank of the bolt, you can have a part of that threaded, or you can have the entire shank threaded. Okay, and so what people do is people say, well, this is the hexagonal bolt with some nominal diameter d. So they would give you the diameter of the shank, the outer diameter of the shank, d. Okay, and you have to figure out, well, by convention, The size of this bolt depends on D. Okay. The minor diameter of the threads, that also depends on D. This guy here, that depends on D, and I'll show you how. One of the conventions that people tend to follow. Okay, so start with the top view. So imagine that you're looking at the bolt from this direction in the top view. Okay. Start with a circle with 1.8 times D, where D is the diameter of the shank. Draw a hexagon, lab 1. The vertex to vertex distance is 2 times D. The face to face distance is 1.8 times D. Okay. Your top view is not yet over, but I have started with the front view. Take the projections. This distance here, okay, this distance here is usually taken as 0.7 times D. Okay. Everything is with regard to or with respect to the nominal diameter of the shank. This angle is 30 degrees. Okay. Draw horizontal. So you get 3 points. 1, 2, 3, 1, 2, 3, 1, 2, 3. With these 3 points in the respective regions, rectangular regions, draw 3 arcs. Okay. Okay. Now look at this guy here and try to compare this guy with this guy. What would this arc correspond to? What would this arc correspond to? It will be essentially the projection of this arc over here. So this nut is chamfered. Okay, so it will be projection of this arc. This here would be the projection of this arc, and this arc will be the projection of this one here. Okay, draw vertical lines. Draw the shank of the bolt, diameter D. Okay, so that measures the outer portion of the threads. Okay, just follow this. You would also be given the length of the bolt and the threaded length, LT. By convention, so this angle is 45 degrees. This angle is 45 degrees. There's a little taper down here. Okay. By convention, we represent the threads by 2 solid lines and 2 thick solid lines and 2 thin solid lines. Okay. And this distance between 2 thin solid lines is 0.8 D. Okay. So these guys, they represent the outer portion of the threads. They represent the inner portions of the thread. This is just one of the conventions that people follow. There are many other conventions. Okay. So those in mechanical, you'll be learning a lot more in 251, ME 251. Okay. Yeah. This one. Okay. In the top view. In the top view, of course, this is symmetric, rather this is axisymmetric. Look at the way I am representing the threads in the top view. The nominal diameter thing is a dotted circle of diameter D. Okay, that's the outer portion of the thread. The inner portion of the thread is represented by 3/4 of a circle. It's a broken circle. okay, and they are dotted because they are hidden, of course. They are dotted because they are hidden. Okay, so if you were to show the bottom view of the bolt, then these two circles, they would have been solid. Okay, of course there will be a bigger circle. Okay, okay, nicey nice or not? No, boring. Too many ratios to work with. Yeah. This one? Diameter of this is D. Diameter of this is? They should be. They should be. They should. They should. So what's your impression here? Boring? Nice? Too many numbers? Boring? Okay. Fine. Too many numbers? Okay. How many of those who say it's boring are in mechanical engineering? Good luck with your 251 then. Yeah? You know, I have the advantage of having a mic, so I can reach you guys. But people who are asking questions, peers of yours who are asking questions to me, if you can lend a polite ear to them, not only will you be able to hear my answer if I'm ready to give that, you'll also be able to hear the questions. Yes? It corresponds to the chamfer on the net. So chamfer on the head of the nut. So see how this is made. So it's not a regular hexagonal structure. So there's something, some manufacturing operation that has happened on the head of the nut, through which these portions, they have gotten smoothened in some sense. Okay? Yeah?
What about the pitch of threading?
Good question. As far as the drawing is concerned, as far as this convention is concerned, pitch is not the information that we provide, but the only information that we provide with the nut is the nut has this nominal diameter D, okay, through which you get the other features, okay, the length of the shank, the threaded length, and the pitch, okay, or maybe pitch is also part of the convention, right? Yeah? What? This one? This one? What should be? All right. So did I ask you to draw the bolt also with your assembly view? Look at question number 6.3. Did I? Yes or no? No? Yes or no? No? You guys are so lucky. But just in case, if I need to show the assembly, the full section assembly, along with the two bolts on the left and on the right. Oh, by the way, before I go there, the nut is going to be something very similar to the head of the bolt, just that this part will also appear over here. Okay, so chamfering at both the ends of the nut. Okay. All right, so this is how the final full section assembly looks like. I'm a little curious. What was that for? I mean, are you trying to appreciate my drawing over here or what? No? Anyhow. Okay. Yeah? Repeat your question, please. Hold on. And can you be a little louder?
So you told fasteners and all are not that important. So why do we need so much detail?
They're not important for what? Just 2 or 3 minutes, I'll be done. I'm going to say this in Hindi. Or maybe not. You're doing 5102? 5102, what's that? Is that a mechanics course or what? Mechanics? Guys. Come on. I'm not as exposed as you are. Come on. Anyhow, so if I talk about mechanics, there's something called a reference frame. Okay, so whenever I make a statement relative to some context. Okay, so the statement that you were making, well, some politicians will say that I have been misquoted. So I have been misquoted. I'm without politics. So when I say they're not important, I speak in relation to or with respect to sectioning. Okay? So in sectioning, I have to make a judgment as to which parts I need to section and which parts I don't need to section. Because if I keep on sectioning everything, then there's no point. No? Okay, so that statement is in relation to sectioning. Of course, nuts and bolts are important. Right? Yeah?
Like, if it is threaded, then there must be something threaded inside the machine also so that it goes inside it. So why are we not inserting the threading inside the groove? Like, there should be or
they represent both, no? Think about that. They represent both. It's a tight fit.
So there is just no threading, it is just used as a point to.
Sorry. So it is this threading that is important, not this one. So this one, the bolt is nicely able to get in. Okay, so there's no threads. There are no threads over here. Okay, so there's some clearance. The bolt is smoothly able to come in, and then it gets fastened over here. So sorry, I mistook your question.
Bolts which are not fastened on the other side by a, they may just be going inside another.
Okay.
Like there's something like this.
Yeah.
Just one thread fits into another thread.
Yeah. So if you think about that, then look at this portion of the drawing. Look at this portion of the drawing. Okay. So the nut and the bolt, they both have interlocking threads. Thank you. I was groping for that word. They have interlocking threads. So the solid line at the outer side and the thin solid line at the inner side, they both represent the inner as well as the outer threads. Right? Think about that. All right, so before I leave the floor, if you draw the full assembly of this, this is how your full sectional front view will look like, and that is how your top view will look like. And just appreciate the clarity at the bottom and the complexity at the top. Clarity at the bottom, complexity at the top, 2 C words. Okay? All right.